We are going to balance this equation by redox method. In this method, first of all, we have to figure out that which substance is oxidized and which is reduced. So we learn what is oxidation and reduction. If oxidation state of a metal is increased, like Fe+2 is converted into Fe+3, that means that more electrons are lost and oxidation occur. Similarly, if oxidation state sum of the metal is decreased, like in Cl2 it is 0, and if it is converted to Cl negative, it gain 1 electron and it is reduced. Shortly, we can say that oxidation is increase of oxidation number and reduction is decrease in oxidation number. So first of all, we have to assign the oxidation number to each of the substances involving in the balanced chemical equation. Right now the equation is not balanced. We know that oxygen has -2 charge and 2 oxygens make it -4. So overall the molecule should be non-ionic, or net charge will be 0. So manganese will be +4. Here chlorine have -1 charge and hydrogen have +1. Now we are going to assign the subject from where we can get to know that which substance is oxidized and which is reduced. As chlorine have -1 charge and 2 chlorine make it -2, and to neutralize the molecule, manganese should be +2. Similarly, oxygen has -2 charge and water will be neutralized in this way, and chlorine Cl2 is pure form and its oxidation number will be 0. Now figure out which substance is oxidized and which is reduced. As manganese have +4 oxidation state and in product it become +2, as oxidation number is decreased, it's mean that manganese is reduced by 2 electrons. Similarly, chlorine have -1 charge and there chlorine have 0 charge. Chlorine is here, it is reduced and chlorine is oxidized by 2 electrons. How it is 2? 1 chlorine lost 1 electron, and in Cl2 we have 2 chlorine, so 2 chlorine have 2 electron. So the next step is to balance these electrons. As we can see that these electrons are already balanced, so there is no need to carry out this step. The equation is balanced as well, but as we know that the substances which are oxidized and reduced are balanced, but the byproducts are not equalizing the equation, so we are going to balance these. As we can see that there are 2 hydrogen atoms in water in the product side and there is 1 hydrogen in reactant side. We have to balance these, but going towards hydrogen, we can see that Cl2 here and 2 chlorine in manganese chloride. Total we have 4 chlorine atoms and we have to balance these chlorine atoms towards reactant, so we can add 4 before HCl. Now chlorine, 4 chlorines in reactants and 4 in product, they are balanced. Now moving toward hydrogens, we have 4 hydrogen in reactant side and in product we have 2 hydrogen. To balance these hydrogen we add 2. Now we get 4 hydrogens as well in the product side. As oxygen, there are 2 oxygen molecules in product side and we have 2 oxygen there in reactants. So all the atoms involving in the equation are balanced in this way. This is the simplest equation. Next we will move towards the more complex one, where we have to balance these electrons also, and after that we can see either the equation is balanced or not. We have studied this balancing of equation by redox method. The main point in this method, I'm writing there. First of all, we have to assign oxidation states. OS represent oxidation state. Next step, identify oxidized or reduced species, and third one, to balance the electrons. By doing these 3 steps, we 98% complete the balancing of equation. We will study the other equation in the next video.